mission to advance the public understanding of science and inspire the next generation of scientists and science advocates. And you can find out more about the Academy and our community-wide events and programs by visiting our website at academyofsciencestl.org. You may also visit us on Facebook or Twitter, or pick up some of our literature that's just outside the auditorium on your way out. And if you'd like to receive e-notification of upcoming Academy and St. Louis Zoo public lectures and events, there are e-news sign-up sheets that will make their way around the audience tonight. We'll have stickers as well after the event this evening that will be available at the visitors desk for any students who need to verify their attendance. And then tomorrow night at 7 p.m. in the Kirkwood High School's Keating Academy and the Kirkwood School, Gay. Dr. Gay earned her BS in astrophysics from Michigan State University and her Ph.D. in astronomy from the University of Texas. She is an assistant research professor at Southern Illinois University, Edwardsville, and is an astronomer, writer, and podcaster focused on using new media to engage people in science and technology. Her most well-known project is Astronomy Cast, a podcast she hosts with Fraser Crane, producer of Universe Today. Dr. Gay also serves on the Council of the American Association of Variable Star Astronomers and is part of the Galaxy Zoo collaboration, a project that invites ordinary people to help astronomers better understand our evolving universe by classifying online galaxy images from the Sloan Digital Sky Survey. Dr. Gay is here with us today to talk about citizen science, from the cosmos to coneflowers, how ordinary citizens can and do contribute to the pursuit of scientific discovery. So won't you please join me in welcoming tonight's speaker, Dr. Pamela Gay.
Well, my computer's fallen asleep, so hold on one moment. Okay. Good evening, and thank all of you for coming out on such a blustery week when I don't know how much snow and ice you had to deal with, but I'm sure the driving hasn't always been good today. Tonight's talk is made possible thanks to the efforts of literally hundreds of thousands of people who over the past several hundred years have slowly been changing our understanding of the universe. The people I'm talking about aren't professional scientists. They're not people who went and got Ph.D.s before they were allowed to go out and look at the stars. They're people who looked at the world around them and got curious and asked, what is this? And started answering questions. Now, some of you in this room tonight are some of the people that helped make this talk possible. And it's my hope that starting tomorrow, more of you will be involved. And the next time I give this presentation, I'll have to change it to meet your new results. Now, when people are asked, who are scientists? Who are these people doing science? Most people imagine some potentially socially dysfunctional male working in a lab with boiling things, electrical things, stinky things, things that no mere mortal could possibly understand. And while this image makes for really good fiction at times, it really fails to convey the real diversity and accessibility of the real science that's out there waiting to be done. The truth is, today, scientific discoveries, from finding new planets orbiting alien suns to rediscovering once thought lost birds in the local woods, all these discoveries are being done by everyday people who've gotten involved in citizen science. The idea of citizen science isn't something new, but it is having a modern-day renaissance. If you're like me, you might not have heard the phrase citizen science until sometime in the past couple of years, if at all. But I'm guessing you've probably known people who've been involved in citizen science. You might have known people who've participated in the Great Worldwide Bird Count or the Christmas Day Bird Count and then reported their results to the National Audubon Society or to the Cornell Ornithology Laboratory. You might know amateur astronomers who chase novae or track asteroids as they move through the sky and then report their results to the Minor Planet Center or the American Association of Variable Star Observers. All these people who are acquiring data and then sharing their results These are citizen scientists. This is what citizen science is. It's everyday people. It's anyone in this room, potentially, going out, observing the world, looking at data, and sharing what they discover, and allowing us to understand more about this universe that we live in. It's hard to know when the first non-scientist opted to make a major scientific discovery. People have always been looking up, they've always been looking around, and people have always been trying to understand what is this crazy universe that we live in. They've been trying to find meaning in the changing positions of the stars and in the motions of the wandering planets. And they've been trying to find ways to measure and predict the seasons, the changing equinoxes and solstices, so that they can better know when to harvest and when to plant. In the architects of the pyramids and in the masons who built Stonehenge, we find perhaps some of the first amateur astronomers, but they wouldn't have exactly called themselves that. We see in the art at Chaco Canyon evidence of understanding the sun's motions. But these people weren't amateur astronomers in the sense that they used their spare time to do science, because science didn't exactly exist when these people were doing their work. The earliest people to study the stars, in fact, weren't scientists at all, but they were keen observers. In the days before science, when gods were responsible for the march of the constellations, and just being a careful observer back then was enough. It allowed you to be able to say, lo, tomorrow shall be the summer solstice. For thousands of years, understanding the sky, and in fact understanding the entire natural world, these were subjects that the Magi studied, that the astrologers predicted. These were subjects for the priests and the wise men of the community. But eventually, through a combination of mathematics and observation, science itself was finally born and taken away from the people and sequestered for somebody else to do. But in the modern era, everyone has taken the time to start looking around and asking questions again. And as we look back through history, we can start to find where citizen science first began again. And one of the things I love is that in the modern era, the first citizen scientists were probably American colonists who recorded the weather. From John Campion's home, who recorded storms in the 1600s, to George Washington, Thomas Jefferson, and Benjamin Franklin, who wrote down the weather while they were busy founding America. These founding fathers, they had this idea that perhaps if they wrote down everything that they saw, they wrote down the storms, they wrote down the rainfall, if they combined their data and they combined the data of the people that they inspired to track the weather with them, maybe if someone wiser than them looked at all of this data, maybe we could start to understand where are the storms coming from. Maybe we could actually understand, is this impeding cloud front going to just fly overhead or dump 50 inches of snow like it just did on the mid-Atlantic states? They were trying to understand the weather. It was Thomas Jefferson who first envisioned a network of weather observers. According to the National Weather Service, Jefferson recruited amateur weather aficionados to go out and record what they saw from 6 different states, including Virginia, Massachusetts, Pennsylvania, Connecticut, New York, and North Carolina. It was on the foundations of this work that in 1849, the Smithsonian Institute set up a means for people to start reporting to a single national location all of the weather observations that they were making. This system is still in place today, and it's called the Cooperative Observer Program, and it's used by the National Weather Service. It's part of how we understand the storms that are going to hit us here in St. Louis and hit all across the United States. It's because of people like you who are still actively engaged in recording what's going on outside. Today, there are over 12,000 stations in this network, 12,000 stations of just everyday people recording the weather. Many of today's citizen science movements found their origins in those early days of American history. John Audubon is perhaps the most well-known of these early role models. Audubon was a naturally curious man, and at the age of 19, back in 1804, he figured out that the eastern phobus bird returns to the same nesting site every year. Now, he was just a mischievous 19-year-old at the time, and what he did was he grabbed a few birds, tied silver string around their legs. This was back before we really did bird banding. And then he released these birds with silver string tied around their legs and looked to see if they came back the following year. And they did. But for him, this wasn't a career. This was just something you do as a young man. He loved trying to understand birds. He loved art. He drew things. But he went on to become a businessman trafficking in dry goods. When he married Lucy Backwell, he settled down and set aside his young curiosities. But then times got tough. He went bankrupt. He needed to find a new way to live his life. And so he decided that he'd try and make a go of it as an artist. And not only that, but he'd incorporate one of his favorite things, birds, into the artwork that he did. In 1826, this American frontiersman arrived in England with a portfolio of artwork that he'd done, traveling all across the United States, drawing all of the birds that he saw. He worked with printers to create the first Birds of America collection, and then went on to create a second book, The Ornithological Biographies, a book telling the life histories of each of the species that he'd drawn. It's the second work that makes Audubon stand out. He wasn't someone who was merely interested in going out and trying to draw every single bird in America. That would be kind of cool. But drawing the birds alone wasn't enough. He had to take it one step further. He wanted everyone to understand what is the habitat of these birds, what is their lifestyle. He wanted them to understand what is the biography of all of these different species that he dedicated his life to drawing. Audubon wasn't what we would today call a tree hugger. He was, in fact, an avid hunter who had a habit of catching the critters he was going to draw so that he could better see his markers. The skunk, it's a Texas skunk, so it's kind of missing the white stripe. In the center picture, the caption, not the caption, the text that he wrote along with this particular print, he describes how he caught it, and it smelled so bad he was pretty sure it was still with him, and it was only that evening when he got off his horse and went to pull it out of the bag he thought it was in that he realized all he had was a stinky bag. He caught things. He released them most of the time. But even though he wasn't what we would recognize today as a tree hugger, he was the founder of today's environmental movement in many ways. It was in his later writing that as the settlement of the American frontiers began to destroy the habitats of the birds he loved, that he wrote that we need to work on conservation. He was concerned that the fragile ecosystems of some of the most exotic and rare and beautiful birds was going to be destroyed and no one would notice. And he asked for people to notice and for people to take care of the environment. It was based on these writings that today's modern Audubon Society found its mission and found its name. And today, based on his ideals, there are hundreds of local chapters of the Audubon Society all across the United States, including the St. Louis Audubon Society chapter. And across the world, there are now tens of thousands of people who are actively engaged in counting the birds and looking to see how are the migratory patterns changing and how are the populations themselves changing as the planet changes. The natural world is a natural starting point for citizen science. It's easy to look around and find all sorts of questions that are just waiting to be answered. And if you happen to be the person who happens to find a giant skeleton in the wall of a cliff, it's kind of hard not to go, oh my God, what is that? And this is where Mary Annings comes in. Some of you as children may have learned the nursery rhyme, or the tongue twister, I guess. She sells seashells by the seashore. Well, what you probably didn't learn is that tongue twister is actually based on a real girl who sold seashells by the seashore. And adding that to a talk is going to kill me at some point tonight. So this real girl, she is someone who had an amazing life without really having an amazing life, and it's an amazing story. Growing up at the beginning of the 19th century, Mary Annings was part of an extremely poor family in Dorset, England. It was, in fact, her and her brother collecting fossils that provided the sole household income when she was a teenager. Her father died of tuberculosis. And she and her brother would collect fossils along the seaside and sell them as oddities on a table where the coach stopped in town. And after the two of them started finding entire dinosaur skeletons, what they were doing went from being oddities sold to tourists to instead being major scientific collections sold to scientists. And Mary Annings found her first skeleton at the age of 15 in 1815. An entire dinosaur as a teenager. That's a pretty neat discovery. And at 25, after having spent many years collecting bones, studying them, trying to understand what she had, she realized that these kind of crazy rocks that didn't really seem like rocks, that were often found beside dinosaur skeletons or inside dinosaur skeletons, well, this was actually dinosaur dung. Coprolites, we now refer to them as. And this was her discovery. It was her understanding. Mary Anning's labor along the sea allowed her to find several ichthyosaur skeletons, a new, I'm going to mispronounce this, I'm sorry, plethosaur, some 5-year-old needs to correct me, plethosaur species, and many other fish and petrosaur skeletons. While never educated, she was nonetheless an expert in what she did thanks to practice and thanks to taking the time to just look at what she was looking for. One of the experts in England in fossils, she was actually recognized by the British Association for the Advancement of Science at the age of 35, and they provided her a £25 per year annuity, which, while it wasn't much, was the very first taste of financial security this woman had had in her entire life. Mary Anning's story is in many ways one of sadness. She was driven to hunt for fossils so that she could feed herself. But she never settled for just scooping up the bones at the water's edge to sell. Lady Harriet Sylvester visited Mary Annings in 1824 and remarked in her diary, "The extraordinary thing is this young woman, she made herself so thoroughly acquainted with the science that the moment she finds any bones, she knows to what tribe they belong. She fixes the bones on a frame with cement and then makes drawings and has them engraved. By reading and application, she has arrived to that degree of knowledge as to be in the habit of writing and talking with professors and other clever men on the subject, and they all acknowledge that she understands more of the science than anyone else in the kingdom." This was a woman who never had an education. The only published work of Mary Annings is a letter that she wrote to the Magazine of Natural History. The magazine had written an article announcing a new shark skeleton that represented a new species of shark that had been discovered. And Mary Annings wrote in to say, no, this has actually been known for a number of years because I discovered it. That's her only writing. The record of this woman's legacy is left behind almost entirely in the words of the academics who provided her the fossils that they worked from. Never married, Mary Annings died at the age of 47 of breast cancer, having spent her entire life walking the cliffs of Dorset chasing dinosaurs. What Mary did changed our understanding of dinosaurs completely and inspired 5-year-olds all around the planet to go out and dig in their backyards looking for their own dinosaur skeletons, that they might grow up to be like the girl who sold seashells by the seashore. At the root of many of these citizen science experiences is a passion that drives someone to explore the world around them and to want to share their experience with others. If you love something, it's hard to not talk about it to everyone around you. In 1873, William Herschel found his own passion for astronomy when he was given a book, when a friend took him out and forced him to look through a telescope, and he got hooked. He started building his own telescopes. He started studying the sky and recording everything he saw. And one day in 1881, what he saw was a small blue fuzzy disk on the sky. And what he saw a few days later was that small blue fuzzy disk had moved. And at first he thought this was a comet, just another wandering object plunging through the inner solar system on its way back out again. But with careful observation, he realized what he'd actually discovered was the seventh planet from the sun. This was the first new planet discovered in all of modern written history. He found Uranus. He wasn't looking to discover something. He was just looking, but he was a careful observer, and he noticed what he saw. And this was one of the things that was most amazing about Herschel. The more he looked, the more he discovered. Herschel realized as he jumped from known star to known nebula on the sky, that between all the objects that we know about, that we knew about, were many, many more small, faint, fuzzy bits that no one had ever mapped. And he took the time to write down what were all of these objects. These fuzzy bits that he recorded are what we now know of as galaxies, as star-forming regions, as supernova remnants. Over the course of his life, Herschel was able to discover, Herschel, a trained musician, an oboist, a composer, he discovered Uranus and its two moons, Titania and Oberon. He discovered the Saturnian moons, Mimas and Enceladus. And along with his sister Caroline, they discovered several thousand faint fuzzy bits, several thousand galaxies and nebula. And their work forms the basis of what we still use, what we call the New Galactic Catalog. Today, amateur astronomers around the world follow in Herschel's footsteps. Herschel was a man who followed his passion for astronomy to a new understanding of the cosmos around us. And you can still do that today. There are still things out there waiting to be learned. And there are amateur astronomers who still every day work to perfect their instruments, perfect their telescopes, and to find the things between the stars that no one has yet discovered. And they're finding amazing things. Just in the past 5 years, we've found new spots on Jupiter that weren't there before. We found a comet that impacted into Jupiter. These weren't made by professional astronomers. These were people outside working in their yard because they were passionate about it. We've discovered stars emerging from the Orion Nebula that weren't visible before. And there are planets being found, and more. Every day there's new discoveries because of people like you freezing to death out in their yard using up what we call spousal permission units, just because they're interested in astronomy. Today, people continue to be inspired. They continue to ask, what is that? And they continue to explore both the planet and the universe around us. Citizen science as a phrase now includes under this umbrella all manner of possible science. And the types of projects that we invite you to participate in is almost unlimited. In the field of astronomy, we need observers. Time on professional telescopes is hard to get, and there are objects that require long-term monitoring, a single observation or dozens of observations night after night, year after year. And those of us who want to study these objects, we can't get time on the professional telescopes. But you and your backyard telescopes, you can fill our need. In ornithology, we need observers. The planet is large, and the number of birds out there is more than large. There simply aren't enough scientists to measure all the changes taking place in migratory patterns and in the sizes of the different populations that are spread out across the planet. To understand all these different changes, we simply need you to go out and look at what's coming to your bird feeder and write it down and report it. In marine biology, we need observers. The oceans are changing as the planets change, and scientists need help spotting algae blooms and spotting cases of coral bleaching while they're still reversible. Scuba divers and recreational boaters can help fill this need and help us understand our changing oceans. In many ways, the thing we need most is observers. Computers are good, video monitoring is good, but your human eye and the human mind are better than any computer. Your eyes can be more places than you can, thanks though to all of these different video cameras, thanks to all of the different imaging systems that are out there. And so if you don't want to be the one outside in the yard, out in the boats on the ocean, well, we have work for you too. All you need is an internet connection. And so I'm going to try and tell you how we can suck you in and why we need you. Part of the reason that citizen science is having such a renaissance is we're facing a complete change in how science is done. On one hand, we still need help filling the data voids. We need you out there looking up, looking around, and recording what you see because we can't be everywhere. We don't have video cameras everywhere, and we need your help there. But more than that, what we're really also dealing with is problems keeping up with the data flood. It used to be that one scientist would spend an entire lifetime chewing away on a problem, on a data set, that you'd go out, you'd gather your images, you'd gather your data, you'd do your laboratory experiments, and that was fine. You and maybe a few grad students would chew away at this and publish papers and then chew some more and publish papers. And for big questions, it might be a few dozen scientists got together and solved the big problem. And when you were done, there wasn't really leftover data waiting for someone else to go through it. Well, this was good. It meant that you never had more than you could really handle, and you never had this moment of complete anxiety attack at how you were ever going to handle all of your data. But it also meant there were a lot of questions we couldn't answer. The sky is big. And in the field of astronomy, this was particularly troubling because in the several hundred years of recorded history, there are some really cool objects that we knew like 3 examples of. And you can't really statistically study anything with 3 examples. So you want more data. And a few years ago, we started to get that more data. Things started to change as technology took over the hard parts of data collecting. And we joined forces with different communities. And out of all of these collaborations and out of this technology, we found ourselves with a problem that we love and we need your help solving. Perhaps the most widely known example of technology meeting a science problem and creating too much data in a wonderful way is the Human Genome Project. Up until the 1990s, people who were studying genetics, they'd go out, they'd collect blood samples, they'd collect cheek swabs, all from a very narrow population. They'd get samples from diabetics, from people with heart disease, from people with red hair, from special interest groups. And they'd sequence the DNA looking for pieces that were identical among all these different samples to try and identify what it was that made this group what it was. But while this allowed us to understand certain small problems in genetics, it didn't go very far to help me understand genetically what makes me me and what makes you you. And this is where the Human Genome Project came in. Using technology, this project was able to figure out how to identify the 20 to 25,000 genes that make up the human DNA. And it's been working to sequence and has actually finished sequencing the 3 billion chemical base pairs that make up your DNA. Now we have enough data to keep basically a generation of geneticists busy tracking down, oh, we have this, that means this, and putting all the pieces together and trying to figure out how it relates to everything in our population. This isn't the only case of a data flood. The Sloan Digital Sky Survey is currently flooding the astronomical community. This is a robotic telescope out in New Mexico that's been working to observe about 30% of the sky. And in this particular set of observations, there are about 1 million galaxies that are close enough and big enough that you can actually start to make out details. You can start to see the arms, you can start to see clumps of star formation. Now the problem is computers can't make sense of that stuff. It takes human beings looking at these 1 million objects to understand them. And we're kind of glad there's only 1 million, because the other several million galaxies in the Sloan Digital Sky Survey are so far away that they're just faint, fuzzy, indistinguishable little blobs. And that's good, because 1 million is enough. Now, all across science, we're having technology changing the paradigm from one single person collecting their single data set and chewing on it for their entire life, being extremely possessive. This is my data, you can't have it. To now we're in a situation of scientists with data going, you have a pulse. Can you help? We need help. There's too much data. And this is where we need all of you to please get involved a little bit at least. Now, we don't necessarily ask everything of you. We'd like your brain, but we'll take your hard drive, There's one set of projects. These are all put out by an organization at Berkeley University. They put together a software package called Boink. And Boink works as a screensaver in a bunch of different flavors. The most famous is probably SETI at Home. It came out in the late 80s. You install it on a computer. It chews away, when you're not using your computer, on radio signals, on observations made with radio telescopes, looking for signals that indicate that, well, maybe there's alien life out there and they use radio. But while SETI at Home is the most famous of these projects, there's actually hundreds of them. There's the Rosetta at Home project, which works to figure out how proteins fold. Because if we can figure out how proteins fold, it'll help us better understand disease. There's projects like climate prediction that work to help us run more and more climate models to better understand how is our planet changing, how do we make sense of all of the temperature data, all of the satellite data, how do we understand what our planet's going to be like 100 years from now. And there's other projects. There's LHC at Home that works to understand particle physics. If you have an area of science that you like, there's probably a Boink project related to it. And being part of this is actually fairly significant. If just 3 of you get involved, and you leave your computer unused for just 8 hours a day, which I hope all of you do, but I know some of you don't, those 8 hours from those 3 people, that represents 1 computer that didn't have to be purchased. Now, if 300 of you get involved, that's 100 computers. That starts to be a lot of money that's getting saved. Because of all of you who have, and who hopefully will in the future, gotten involved in these different projects, science that otherwise couldn't be done simply because the scientists can't afford to purchase the computers is now possible. Your computers simply become the supercomputers when used in aggregate that churn away to help us understand all the data we have. And there's other ways to passively get involved. You can install weather stations all across the United States. There are schools, there are homes, there are businesses, there are farms that have installed weather stations that it's nice to know, wow, that rainstorm was 8 inches of rain. But that information, when uploaded wirelessly to the National Weather Service, helps us understand what's going on out there. And there's other ways to get involved. You can install a bird box, just a happy little bird house like you might build with your 10-year-old, and then you stick a camera in it, and you record what the birds are doing, and you attach this to the internet. You can watch for your own fun and pleasure, but by letting the information go up to the Cornell Ornithology Lab, you can help everyone understand what's the development of some of the local birds in your community actually look like. And if you want to get involved in a more direct way, on the right-hand side of this video is the sun. And the sun likes to do nasty things. Specifically, it periodically gives off bursts of high-energy particles called coronal mass ejections. When these storms are directed directly at the planet Earth, it causes bad things to happen. Small ones cause amazing aurora, amazing northern lights. But really big ones can shock the electric power grid by doing bad things to the magnetic field of the planet. And few of you may remember a while back when Quebec kind of lost the North American power grid. That was caused by one of these. So understanding that these coronal mass ejections are coming our way is an important thing. And so NASA has launched the STEREO mission. It's 2 separate satellites that one is moving ahead of the planet Earth and the other one is lagging behind in orbit. So if you have the Earth over here and the sun over here, the coronal mass ejection has to go between STEREO A and STEREO B. And these 2 little spacecraft are watching the space that the coronal mass ejections would move through, waiting to catch something that's about to do a bad thing in the act. And these particles, they're not moving too fast. They get from the sun to the Earth in a few days. But light travels a whole lot faster than that. So the images can make it back faster, and we can put satellites into safe mode. We can put astronauts into safer places. And this form of space weather prediction, which NASA doesn't have the manpower to do, you can do instead. This website, Solar Storm Watch, it's put together by the same people who are behind the Galaxy Zoo project, which I'm about to talk about. This particular site is put together by the National Maritime Museum, which is the host institution to the Greenwich Royal Observatory over in England. It's a British project, but we like them anyways. And they don't care where you're from. They just want your help looking at how our sun behaves and misbehaves in its day-to-day life. And this is perhaps one of the most famous of these citizen science projects. This is Galaxy Zoo. Now, how many of you in here have zooed? Oh, come on, I'm seeing one hand. Is there only one person in here who's used Galaxy Zoo? Okay, so you all have, 2, yay. Okay, so the rest of you have a homework assignment. You won't be graded, it's all right. The Galaxy Zoo project launched back in 2007, and this science project tells the dirty, dark side of where good ideas come from, because it came out of being angry in a pub. Back in 2007, there's a grad student at Oxford University who was handed a chunk of the Sloan Digital Sky Survey. Specifically, he was handed 50,000 galaxies and told, go find the ones that are little fuzzy, elliptical, boring things. And he went away, and he came back a month later and said, here, I'm done. And his advisor looked at what he'd done and said, very good, go do another 50,000. At which point Kevin, depending on who you hear telling the story, and I haven't asked Kevin yet, Kevin may or may not have told the advisor where he could put the 50,000 more galaxies that he was being asked to look at. Now, Kevin Zvinsky, although Swiss, did a very British thing at this point. It was a Friday afternoon, he went to the pub. And the British have this wonderful word that we need to import. The word is whinge. It's a combination of whining and cringing, and we've all been there. And Kevin went to the pub, and he whinged about how he was being asked to look at another 50,000, you can imagine what the rest of the sentence was, galaxies. And Chris Lintott was there, a postdoc at Oxford University and co-host of BBC's The Sky at Night, very interesting human being who lives 2 wonderful lives. Chris said, well, why don't we just put them on the internet? We'll get the public to look at them. What to Kevin was a nuisance of having to look at 100,000 galaxies. You could take all million from the Sloan Digital Sky Survey, throw them out on the internet and say, can everyone look at just 10? And suddenly the problem is no longer intractable. And so they got together and they got other people together and they built this website and they launched it the summer of 2007, and a few hours later the server melted. This is where the other part of Chris's life becomes important, because since he worked for the BBC, he was able to go on the BBC morning show and announce that they had this cool project. And suddenly people who would normally be playing Minesweeper or Sudoku were instead classifying galaxies, because they're prettier. And it melted the server. Today, this website has collected over 50 million classifications of galaxies. Over 250,000 people from all around the globe have gone and registered to take part. And out of the work of these people, last count I had, and it changes on a weekly basis, there were about 20,000, there were about 20 different journal articles that were submitted. It feels like 20,000. There were 20 different journal articles submitted or accepted to peer-reviewed journals. And what's amazing is some of the coolest discoveries coming out of this project aren't ones where the scientists were combing through the results of what the people clicking on buttons had found, but rather they came out of the people clicking on things, talking to each other in the forums. Up in the top of this graphic, there is a green blob that rather looks like a dancing frog. This is Hanny's Vorwerp. She was classifying in the interface the galaxy up above the head of the dancing frog, and she classified it, spiral galaxy, no big deal, move on with life, and then went into the forums and went, what's this green thing, what's this Vorwerp? And no one knew that Vorwerp was just the Dutch word for thing, and they thought it was something cool and special, so it's now Hanny's Vorwerp, which just means it's Hanny's thing, which is far less exciting. But the scientists in the project, they didn't know what this was. And after a lot of investigation and a lot of follow-up telescope time, it was realized that Hanny's Vorwerp, this is a blob of gas being illuminated by a beam of light that its source turned off. We don't think of it this way, but when you turn a flashlight on and off, that beam, it keeps going. Flashlight off, beam still going until it hits a wall or whatever. Well, that galaxy up above the dancing frog, if you could see this in 3 dimensions, you'd realize galaxy, dancing frog. Galaxy's axis pointed directly at dancing frog. It used to be that there was a supermassive black hole up inside the galaxy that was angrily eating food, eating dust, gas, planets, stars, whatever black holes decide they want to eat. And all of this material heated up. It lit up. It sent off jets of material, jets of light. And the black hole's not eating anything anymore. But the light that it gave off, it's still traveling. And that light is currently hitting this blob of gas and dust, lighting it up bright, in this image, green. In different images, it looks bright blue. It's actually bright blue. This telescope just made it look green. And that's kind of cool. And this was discovered by a Dutch school teacher who took the time to ask, what's this thing? Now, these other much, much more boring green-looking things, these are the peas. One day, someone who kept noticing these things off in the edges of their image took a snapshot of one, dumped it in the forums, and wrote, "Give peas a chance." This started a punning where the rule was, if you found a pea, and only if you found a pea, you could write a pun. And we all like to pun. There's some evil little part of every person that wants to write a pun. And so pretty soon they'd collected several hundred of these things. And then they started looking at them. What are they? Well, it turns out these little green blobs are massively star-forming dwarf galaxies that had never previously been known. Because of a pun, we have to rewrite textbooks. This is a new class of galaxies that is now called the Ps. Small, massively green star-forming galaxies, discovered by people who took the time to be silly, but then to ask, what is it we're being silly about? It was them who figured out that this is something entirely new. Now, while I have a soft spot for astronomy and am going to hit on astronomy far too much tonight, this is the coolest project. Now, I will warn you now, if you go to their website live, one of the 3 videos that pops up on the front page is owls producing baby owls, so don't ever go to this page live in front of an audience. I tried that once. I will never do that again. The other videos, one includes popping baby birds. This project, the click cams from the Cornell Ornithology Lab, they ask you to look at videos of nest cams and write down, well, actually drag and drop, what exactly is going on in the nest right now. Are there eggs? Are there parents? Do you see feeding activity? How many of the parents are there? All they want you to do is look at adorable bouncing baby birds, and sometimes much more boring eggs, and sometimes owl-on-owl action. But this is science, because you looking at these videos allows you to find all the cool bits, and then the scientists to do all the statistics on the cool bits. But it takes lots of eyes to find all those cool bits. Now, some of you like to actually go outside rather than simply sit behind your keyboard, and I respect the need to be outside in nature, and you can do it in the dark. These are 3 different astronomy projects. I gave the websites at the bottom. Don't scramble to write them down. I'm going to put this stuff up on my website later. These 3 projects are 3 different ways that you can observe the universe. The one on the far left, this is the graphical representation of the Epsilon or Rigi system. There's a project called Citizen Sky going on right now. Every couple of decades, a giant disk of material passes in front of a normal, everyday, happy, very bright star and causes the normally happy, very bright star to get to the point that you can barely see it in a light-polluted city. And that's okay. Eclipses happen. We know how to understand those. But the thing is, in the middle of the disk passing in front of the star, all of a sudden, there's a hole in the disk. that allows us to see through to the star on the other side for a brief brightening period. And the last time this happened, we were still building digital detectors, and so people didn't fully understand what's going on. Well, today we have you to help, we have digital detectors, we have space observatories, and dang it, we're going to understand what the heck is going on by asking the entire planet to help. And it looks like this might be black hole, disk of stuff around black hole, and who doesn't want to look at a black hole, passing in front of normal, healthy star. This is a weird system, and to fully understand it, we need you. Now, some of you may want to look at more than one object, and this is where transitsearch.org comes in. This is a group that is working to try and find all of the times that you have a star, you have a planet, and this star isn't the sun, and the planet passes in front of that star, and we can see that happen. Because when a planet passes in front of a star, the starlight going through the planet's atmosphere allows us to measure what's that planet like. Now, I happen to have a bet with Seth Shostak that we're going to find life on another planet, or at least plants and algae, by looking at sunlight going through an oxygen-rich environment before we start to catch radio signals. We're going to find habitable worlds by finding transiting worlds. And there's a lot of planets out there that we know about, but we don't know which of them pass in front of their host stars. And you can help do this. All it takes is a 4-inch telescope and a whole lot of being overly careful about what you do. It's hard, but it's something you can do with a 4-inch telescope. Now this last one, that's a star exploding, and those are just cool. There are lots of different organizations that work with satellites to find out when do stars go supernova, when do they simply have a flare activity, when do they explode as a gamma ray burst. And when these things happen, there are astronomers all across the world whose cell phones vibrate, whose computers have pop-ups that tell them, go take a look. And it's because of all of these different people tracking what happens when these stars go off that we're able to consistently get good enough data that we're starting to actually understand how do gamma ray bursts explode. These are stars that if they exploded too close to the Earth would just destroy our planet. I'd like to understand that. There are normal nova, which are just stars that suddenly pop out and become visible on the sky that didn't seem to be there to the eye a few days before. Understanding all of these high energy processes, who doesn't like explosions? You can help us do that. And then there's daytime activities too. Now I've mentioned birds a lot. Everyone knows about the bird projects. Audubon has great PR, Cornell Ornithology Lab, great PR, but you can go out and look at the bees too. This is the Great Sunflower Project. Some of you may not have heard, but globally we're undergoing a bee crisis. We're still trying to figure out what's going on, but bees are disappearing. And part of trying to understand where we're losing the bees and why we're losing the bees is having people go outside and count them. So the Great Sunflower Project asks you to plant sunflowers, to plant cosmos and coneflowers and all of these other plants, bee balm, that bees like. And then once your flowers are blooming, to go out and spend just 15 minutes looking at a single plant and counting all the bees that come to that plant and maybe taking photos of them. One of the things that really made me sad is last year, 20% of the people who went out and looked for bees didn't have any bees in their garden. And so this is something we need to try and understand because bees are necessary for agriculture. So you can plant some flowers and make your yards a little bit prettier and do science just by looking for the bees. And for those of you who like your bugs a little bit less dangerous, there's the Lost Ladybug Project. Now, here you might have experienced when they were harvesting all the soybeans what looked like little orange ladybugs everywhere. No, those were not ladybugs, those were soy bugs. And this is the thing, those aren't native to America, they just got here. There's lots of bugs that are ending up in America via cargo ship, via shipment of vegetables, all sorts of different ways. And the native ladybug species are struggling, they're changing, they're migrating, and sometimes they're disappearing. And so the Lost Ladybug Project is asking for people to go out and, well, look for ladybugs and take pictures of them. And it was through the Lost Ladybug project that they actually were able to rediscover a lost, spotless species of little red ladybug out in the Northeast. And that rediscovery of a species that had been gone for 14 years was made by someone participating in this project. And then there's my favorite, which is Project Squirrel. This is a project to figure out how are the red fox and the gray fox populations changing. And some of the results to come out of this are you find fox squirrels in suburban areas, and you find gray squirrels more in urban areas. And at first thought, you might think it's because of the people. Well, it's actually because of the cats. When you have people in single-family homes, they tend to have cats they let into the yard, and the yard cats tend to do bad things to the gray squirrels. And this stresses them out. And fox squirrels, if you try and find an image of a fox squirrel on the internet, there are a lot of like sumo wrestler fox squirrels out there. And the cats and the fox squirrels are pretty much okay. And so it's things like understanding cat versus person versus squirrel relationships that Project Squirrel is working to sort out. And what's amazing is just how cool some of the things being discovered are. I just have to highlight this. The Hubble Space Telescope wasn't supposed to be announcing any images until January. But this particular image, you'll notice, July 23rd, 2009, not January. This is because Jupiter got whacked by a comet, and that's cool. And so they took pictures of it. And we knew that it got whacked by a comet because someone standing in their yard, looking through the eyepiece of their telescope in Australia, discovered there's a black spludge on Jupiter that hadn't been there before, and they reported what they saw. And because of that, and because that is such a rare event, at least we thought it was supposed to be a once every 500 years thing, and it's happened, what, twice in the past 20 years? But this was something that was so special that they turned Hubble on and released the images early so that we could see it. Now, there's other ways to get involved. This video that's about to play, it's pretty cool, but the reason I'm playing it isn't because of the science behind it, but because of the person behind it. This is the work of Doug Ellison. He's a computer programmer, he's a hacker, he likes to hang out online, resembles a lot of the people in this room, I'm fairly sure. And he likes to play with NASA data. This is all real images. These are things that he's put together from the different Mars missions, the HiRISE mission in particular. And he's zoomed in and he's spiraled and he's made it artistic because for him that's fun. And because of this, you can actually start to get a much better feel for the geography of Mars than you could ever get just looking at a single image. And there are lots of ways that everyday people can get involved using their normal workday, have to use it for work skills. Computer scientists are expensive. NASA can't afford that many of them. But what might be work for some overworked individual at NASA, for Doug Ellison is play. And because Doug Ellison plays, you get this view of Mars that you would normally never, ever get, which gives you a deeper understanding for how wonderful the surface of Mars really is. It's in the imaging skills that we find lots of beauty that we otherwise don't get, simply because the folks at NASA are really, really busy. Now, how many people in this room are old enough to remember the data coming back from Mariner 10, back from Mercury? Several of you. Now, what you saw was the image on the left. Kind of cruddy, kind of hard to see where craters begin and end, kind of hard to understand the surface features. The image on the right is the exact same set of NASA data, exact same data, but put together by a graphical artist. This is done by Ted Steike. And in his real life, he's not even, this isn't how he earns his living. He's actually, I think, a philosophy professor. But like a lot of us, he plays with images online. We've all photoshopped our buddies at some point or another. We've all put ourselves in a foreign country. He created other planets that looked prettier. And because of his work, we have a better understanding of the surface of Mercury. Because of his work, we can better trace the minerals on the surface and we can better count the craters. And he's been doing this for all the little rocky worlds all across our solar system, taking NASA data that was put together by overworked, tired NASA individuals into quick, let's just get this out to the press images. And he's put them together in ways to allow scientists to do better science. Now, this is our hope for tomorrow. We want you to be a part of this. And today we ask you data, us. We need you in there finding the cool things for us to follow up, finding the mathematics, finding the statistics, finding the birds, the ladybugs, the bees, the variable stars, the supernova, the coral reefs. We need you out finding the data and helping us understand what's going on. But as the instruments get bigger, the flood is going to get worse. There's a new mission orbiting the moon, the Lunar Reconnaissance Orbiter. It's going to be outputting on the order of 190 gigabytes of images per night. This is going to become many thousand lunar cutouts that are going to become part of a new project called Moon Zoo. I showed you Galaxy Zoo, I showed you Solar Storm Watch. Well, at the end of March, we're coming out with Moon Zoo as well, where we ask you to help us count craters and find dead robots. We're going to be exploring the surface of the moon using data from the Lunar Reconnaissance Orbiter, and we don't know if we can keep up. And we think we're just barely going to be able to. If we get like the whole planet involved, and we have that goal, and the BBC is going to help, and I hope all of you will help. Now, in a few years, we're going to be launching, not literally launching, but we're going to be opening for first light the Large Synoptic Survey Telescope. It's going to be imaging the entire sky that it can see 3 times a night. It's thought that it's going to have about 10,000 triggers on random special events each night. That's a lot. We don't know how we're going to keep up. So in preparation for that happening, we're working to train computers to do the grunt work, to do the boring work. There is actually funding to do, it's not the X Prize, but it's the cheaper, smaller National Science Foundation funded version of a series of algorithm prizes where in the next few years you're going to see, okay, start your computers, figure out this problem for us. Our first attempt at doing this is a project called Merger Zoo, where we ask people to run simulations on their local computers to understand galaxies merging. And we're going to get more and more complicated. And so the idea is these giant survey telescopes, giant coral reef investigating video cameras, all these other projects coming in the future will send all of their data to computers. And the computers will chew, and go, understand, ooh. And the things the computers can't do, we send you. And you look at them, and you go, oh, the camera just screwed up. Or, oh, this is 2 objects overlapping. Oh, this is what happens when you have mama bear and baby bear. It confuses the software. And you sort out the stuff that's just normal, but the computer couldn't quite get. But then you find Hannu's Vorwerp. Then you find the green peas. Then you find all the things that we don't know are out there. And we follow up those particular objects, those particular places, those particular experiments to better understand all of the really interesting stuff that it takes the human mind, the human eye, to see, to notice, to sort out. We need you to be a part of this. And it's a great new future that we're moving into. And it's the first time when I think we can say it takes the whole world to do science. And I'm hoping that all of you will join us. I'm going to be putting all of these websites up on my website, which is starstrider.com. And if you want to be a part, come visit and you can learn all about it. Thank you very much. So I think this is where you get to bombard me with questions. Yeah. Netbooks weren't designed for this.
Well, it wouldn't, and then you have to go back and tell it to run 80 or 50%, and then it just got to a tiny count, so I don't think it's going to.
Yeah. No, it's true. Not all computers are equally capable. I have a netbook. It's very cute. It fits in my pocketbook, and people don't know I'm carrying a computer with me, so I can be a nerd anywhere and do it covertly. But at the same time, my little netbook, it just barely creeps along. And things like SETI at home are expecting modern computers, and netbooks, while cute and capable, aren't designed. Okay. Okay, wow, okay. So they did not optimize their software, and I apologize. Okay.
Because my own computer went dead because, I don't know, it got dusty or something, and so the fan was always going, and so the battery was dead in 1 hour. So I didn't want to do that in my new computer.
No, no. So, yes.
Related to that, I've heard of, I don't know the name of the program, where they use PlayStations for protein folding.
Okay, that's folded.
Folded, okay.
Yeah.
Because they actually have really good processors, and then as soon as the kids aren't playing inside, you know, they can actually go around.
No, it's true. It's we want your CPUs. We want your brains, but we'll take your CPUs. Other questions?
Can you run more than one of those at a time?
No. But you can swap off which one you're running at a given week. So just round robin, the same way you might change the background on your screen because you're bored of it.
Boink and unfibers all and cycles through.
Really? Okay, I'm corrected. I haven't looked at it in a while. Thank you for that. Okay, I guess it can run more than one at a time. Last I looked, you couldn't.
Well, in cycles, you can just choose the ones you want and go.
But that still doesn't require human intervention, which I think it solves your dilemma of not having to manually change things. And I can also answer astronomy questions and the occasional non-astronomy science question as well. Yeah.
I do a fair amount of wildlife observation, just on an amateur citizen science level, and I've been wondering about, hey, what's the best ways to contact scientists that I know are experts in particular fields and say, hey, I've seen this cool thing, is this worth exploring, trying to get published, what have you?
Right.
Is there sort of good etiquette, bad etiquette?
So
Get a lot of the blues and kosher.
So there's three things to take into consideration. One, scientists as a whole are underpaid, overworked, exhausted human beings. So you want to try and find one who's most susceptible to getting an email. And there's two routes for doing that. One is to find the projects that are actively already looking for people like you. There's an entire listing of all the citizen science projects off of the Cornell Ornithology site. So I'll put links to that on my blog. So you can troll through the citizen science projects, find them on one most related to what you're doing, and they have scientists who are dedicated strictly to working with people like you. Now, it could be you've managed to find something that doesn't actually match a citizen science project. In that case, the people who are most likely to be receptive are the youngest people you can find. So you want to find the least gray-haired, youngest person, a postdoc, because they're trying to find research to do. And they don't have as many bureaucratic responsibilities and service responsibilities and travelers. So find the person youngest, most likely to have time, and then say, look, here's exactly where my data came from. Here's my question. Don't try and solve it for them until you've convinced them you're not a crazy. That's the most important part. All of us, even grad students, get letters from crazies. So make sure that you're non-crazy classified before you start offering solutions. Go ahead. There are seismology programs. I have to admit, I don't know anything about them. I'm sorry. Yeah.
How would you get advice finding
Every single one of these citizen science projects has a how to take data section that teaches you. There are very specific ways that they recommend, and often they'll have PDFs that you can print out of example data logs. There's certain characteristics you always want to record. What time is it? Where are you? Photo documentation is always good. But then, depending on what specific science you're doing, they're going to ask for other things. So they may want to know, is it feeding, is it singing? And exactly what they want to know is going to depend on what you're contributing to. So go look at the websites, and they always have these wonderful tutorials on how to provide your data. And always remember, no matter what you're doing, write down what time it is and where you are. Because without those two pieces of information, your data can't be used. Everything else, they'll tell you. Yes?
I'd like to get a telescope.
Cool.
And what would you recommend is what is important as far as buying a telescope?
Okay, have you ever had a telescope before?
I have a little, one, but it's pretty cheap.
That's okay, we all start there. Okay, so the reason I start by asking that is because if someone's never had a telescope before, my next question is, have you had binoculars? And if the answer is no, I say buy binoculars. Always start with binoculars, because there's none of the pointing difficulties. We all know how to, well, it's actually harder than you'd think, but you can find things in the sky with binoculars. And once you reach the point of sky no longer cool with binoculars, then you get a telescope. And for your first telescope, what I recommend is getting what's called a Dobsonian telescope. These are giant light buckets, but they're light enough weight that I can pick one up and carry it out into the yard. Now, well, okay, some of them are. They can get bigger than my car. Your normal couple $100 Dobsonian telescope, and there's a really good one available from Orion Telescopes called an IntelliQuest, that it has little encoder bars on it and a little computer that it says point at and name something really bright that your magazine finding chart will have, and you slew it over and you point, and they're easy to move because you grab the front, you hold the back, and you move it like you're moving a cannon, and they look kind of like a cannon. And once you've aligned on 2 or 3 really bright objects, it knows where it is, and you haven't had to do any fussing. It just knows. And then you can say, show me Jupiter, and it'll take you to Jupiter. But you're the one still moving the telescope. So you start to learn how to move around a little bit better. Now, you can start with one of these that has a 6-inch, and you can usually get them for a couple $100. And with a 6-inch, you can start to see galaxies. You can start to see the summer sky all along the disk is just filled with nebula and star-forming regions, and it's really cool. Eventually, you will outgrow it and become obsessed. I'm just going to warn you now. This is true of any hobby. My advisor in graduate school was a birder. He spent as much in 1 year on his birding trips and equipment as he paid me in salary. They say that an enthusiastic hobbyist whose children are no longer living at home will spend as much on their hobby as they spend on their car. And I think it's true. So pick your hobby wisely, and hopefully it's not one that takes up all the closets in your house. Those of us who knit know what I'm talking about. When you get obsessed, your next step is, of course, to get something that's computer tracked that you can mount cameras on, and then you get into the whole astrophotography thing, and it's all hopeless. But you have fun, and then you can start hanging things on the walls. But get your Dobsonian first. They're fun. And there's a bunch of guys, okay, I'm recognizing all sorts of astronomy club. The St. Charles Astronomy Club is in the house. All of you astronomy club people, raise your hands. Yeah, all of these people, they can help. Okay. Other questions? Yeah.
But you said how important it was to take data. Did you know the story that Galileo was the first person to see Neptune or no?
Right, but he, didn't.
We never reported it, but he had
Right. No, it's one of the great frustrations is there's sketches, and he was obsessing on Jupiter and its moons, and they can figure out exactly when the sketches were made, and they can figure out what should have been in the field, and yeah, he missed a great discovery. But that's okay. 400 years ago, he was responsible for a lot, and fighting with the entire Holy Roman Empire pretty much at a certain level. So we'll forgive him that one. He did make science a process. Before him, experiments weren't how science was done. It was philosophy. And so I'll take creating the scientific method and missing a planet any day of the week. Yeah.
Do you have any, I guess, resources or ideas on how you would implement citizen science into, say, an introductory astronomy class or a K through 12 science class?
So I'm part of the Galaxy Zoo collaboration, which is now growing into the Zooniverse collaboration. And at the end of March, we're going to be launching an encyclopedia of content. Most of it astronomy to begin with, and that's just the first step in creating an entire educational website where we are going to be creating teacher resources. For now, the best way to get involved is to talk about, well, it depends on what grade you're working with. If you're working with little kids, you just want to do pattern matching. And so you make it a game. What's the diversity of things in the sky? Let's look at them in Galaxy Zoo and then do pattern matching. It's actually easier to bring Galaxy Zoo into mathematics in some ways, because you can get all of the kids in your class who are looking at completely randomly selected galaxies from a sample of 250,000, and some of them will get 3 spiral galaxies, 5 ellipticals, 2 blobby crazy things. Others will get all orange little tiny boring blobs. Some will get 2 or 3 fabulous spirals, and then everything else boring. But all of the statistics will vary. But you can average things together to find out what the universe looks like. And you can run this experiment 3 or 4 different times, and you'll keep getting the same averages. And so this starts to allow you to say, okay, you might get one set of results, you might get another, but when we put all the results together, now we can understand the universe. So it's with statistics that it's the easiest to teach it. Now, when we start doing Moon Zoo actually aligns a little bit better with state standards, because you can start talking about the evolution of things, the changing surfaces, and whacking the moon with asteroids creates craters. And anytime you're whacking something, little kids get excited. And so once we start talking about the moon, you can do in cratering, you can do the experiment of, okay, cocoa flower throw things, create craters, and then you can start looking at craters on the actual moon. But we'll have an entire website in about 6 months of all educator resources. And right now, if you go to the Galaxy Zoo forum, there's an entire section for teachers broken out by different grade levels. And there's people who are already doing this in the classroom who can help you. Other questions? Yeah.
Is that website on your website? What you just said with the teachers?
I'm going to put, so if you go to starstrider.com, written in very gray letters that looked less gray on my monitor at home, there is over on the right a picture that says Galaxy Zoo. That will take you to the main Galaxy Zoo page, and you can get everywhere from there for the Galaxy Zoo related projects. And where you want to end up is the forums for discussions for educators. And it's just galaxyzooforum.org. Other questions? You have 7 more minutes that you can torture me. Yes.
This is way off in a wildly different direction.
That's okay.
Because I've been watching television a little bit.
I do that too.
Winter solstice 2012.
Oh, I love this one. Yes. Okay. So the internet is insane. Not everything on the internet is true. So there is a fact that the Mayan calendar ends in December of 2012. Now the thing is, all that means is it's going to start over again. Now the Mayan calendar is just basically a whole set of numbers that they tried to find the lowest common denominator for, and it ended up being a huge number. Because, well, not lowest common denominator, they're trying to find how many times does it take for them to line up again. So it's sort of like, have you ever watched windshield wipers that are going at different speeds? They start like this, but then they get like crazy, and then they end up back together, and then they get crazy. And I can't do it with my arms while talking, but we've all seen windshield wipers do it. So it takes a certain number of back and forth in getting out of cycle, which really I can't do, before they get back in cycle. And the number of cycles it takes for them to get back, that's the type of thing the Mayans were looking for. So they're like, okay, how many years do you have to wait before you have full moon on the summer solstice a second time? Okay, that's kind of cool. Now let's see what other numbers we can add in. Let's get Venus in there. Let's get the pregnancy cycle of a woman in there. Let's get the menstrual cycle of a woman in there. Let's get the amount of time it takes. They added all sorts of crazy stuff in there. And when they multiplied all these numbers together to figure out, and literally the multiple of pregnant ladies is one of the numbers in the Mayan calendar, how many times it would take to get everything to cycle back, they finally get to that number in December of 2012. And then it just starts over. It's just a cycle. It starts over. But there are crazy people out there who think that because an integer number of all of these cycles where they all line up perfectly is being hit in 2012, this means everything will end. Now, there's a lot of people that you think are normal who believe this. Erin Gray from Buck Rogers in the 21st Century looked great in spandex. She's one of these crazy people. There's lots of them out there, and we need to find them and educate them. Now, the problem with crazy people is you get one crazy idea in the room and all the rest come up to the surface. One of the other things floating around on the internet is, oh, the planets are going to line up with the center of the Milky Way galaxy. No. That actually happened in 1998. We've been there, nothing bad happened. It was okay. It was kind of cold in San Francisco. It was actually the coldest winter they'd had in a long time. Wasn't the end of the world, just required a wool sweater. So we've already lived through that one. The other thing that they're talking about is we're going to have a planet, Nibiru, coming in from the outer part of the solar system. It's going to come crashing in, destroy everything, send comets, asteroids everywhere. If this were happening, it would already be a naked eye object that you could see if you went outside tonight. And you can't, it's not there. So there's all of these different things that people are saying on the internet, and they're saying it with authority. The planet is going to flip over, apparently. We're going to have the north and south poles change, or if not that, there's a more moderate version of the planet is simply going to tilt 23 degrees. There are those who even claim this has already happened. If it had, the North Pole wouldn't be the North Pole anymore. Or at least the North Pole star Polaris wouldn't be the Polaris North Pole star anymore. Hasn't happened, not going to, unless we get hit by an object that doesn't exist, that we would have seen already. We're fine. Now, unfortunately, the number of crazy websites outnumbers the number of skeptic, sane astronomy science sites. And at a certain point, don't numbers mean truth? No. Unfortunately, crazy people on the internet outnumber the sane people. But all of you have voices, so next time you hear someone worried about 2012, tell them, yes, the Mayan calendar is ending, it's just going to start over, it's pretty, get a piece of jewelry made out of it, it's okay. And all the rest of it is just made up. It's okay. Move on. It's okay. What? It makes very good movie fodder. That still doesn't make it true. Yes?
Some of that stuff's on Discovery Channel.
Yeah, I know. It has good ratings. That's the problem. Crazy people watch TV.
That's what I said on Discovery. One thing there's on Discovery Channel, maybe I'm wrong, but it seems like there's talking about other universes out there that.
Oh, yeah, that one actually could be true. So that falls into the land of things we can neither prove nor disprove. I actually have an entire talk on that. I'm not going to give it right now. No, if you're interested in that, there's a really great book by a man by the name of Larry Susskind called The Cosmic Landscape. And the idea is that we have this problem where one of three things is true. life is hard to get to, and you had to have the exact right physical parameters in order to have a universe capable of supporting life. I'm not saying life on Earth hard to get to, I'm saying a universe capable of life hard to get to. Now that we have life here, it could be everywhere, we're good with that. But getting to the stage of having life is hard. And there's 3 scientifically valid explanations. There's underlying physics that we just don't know yet that says the universe has to exist the way it does. Cool. We want to find that. It's all right. We just need to find it, not there yet. The other possibility is if you create enough universes, some of them will be capable of supporting life and most of them will kill people. Scientifically valid theory as well. This is the multiverse theory. The third theory that most scientists sort of like, is that there's a God out there, and science can't answer that one, can't test that one, can't go near that one, and that one isn't mutually exclusive to the other 2. So you can have God plus single universe, God plus multiple universes. Science can't tell you if God is there. So that's the universe we live in. We can't prove that we're the only universe. We can't prove that there's other universes. We can't prove that there's God using science. So multiverses could be possible. That not so much, no. You can get multiple universes, but only at the moment of the Big Bang. So.
It's hard enough to understand this one.
Yeah, sorry. Clearly, okay, I need to put that talk online somewhere. Okay. It is 9:01 and 23 seconds, but I'll take one more question. Or I'll tell you all you've been a wonderful audience, and thank you all for coming out on a snowy evening. Thank you so much.